discuss and demonstrate some aspects of temperature and internal energy. Here I have a statement about temperature. Temperature is a measure of the average random kinetic energy of the atoms and molecules in a substance. Whereas internal energy is the thermal kinetic energy plus potential energy of interaction of all the atoms and molecules in a substance. Now I'm going to demonstrate some aspects of temperature. Here I have a molecular motion simulator, and in this chamber here I have some glass beads, similar to the glass beads that I have in this jar here. I'll show you that these are just glass beads. I'll pour them from one jar into the other, and so we just have some glass beads, and then on this, on the bottom of this, there's a disc that spins, and when I turn that on, that disc will spin. It's got some little bumps on it that'll send those beads flying around in there, and those beads will move around and simulate, as we increase the speed of the beads, it will simulate an increase of temperature inside of this chamber here. So when I turn that on, you'll see the beads speed up, and you'll see the pressure tend to build up on the bottom surface of this plate. That'll push this plate up and cause the volume to expand as a result of that temperature increase. So I have a light there to help illuminate those beads, and then I'll turn a switch here, and that'll start those beads into motion. So as we increase the speed of the beads, that simulates an increase in temperature, and of course if it's a gas, it'll cause the gas to tend to expand. Now I'd actually like to demonstrate real temperature here with the aid of our digital thermometer. We see that it's reading a temperature now in the room here. The probe here measures the temperature. The end of this probe has a sensor that measures the temperature. And this readout here is reading about 19 degrees Celsius right now. That corresponds to a temperature of about 66 degrees Fahrenheit. And here I have some liquid thermometers. One reads Celsius and one reads Fahrenheit. And the Celsius is reading about 19 or 20 degrees Celsius. And the Fahrenheit thermometer is reading about 66 or 67 degrees Fahrenheit. So that's the temperature in the room. Now let me measure the temperature of the water here. Again, temperature is a measure of how fast the molecules are moving. It's a measure of the random kinetic energy due to the translational motion of the molecules. So it's a measure of how fast those molecules are bouncing around. That's true whether it's a liquid or whether it's a solid or whether it's a gas. And so let's go ahead and add some heat to this water and see if we can raise the temperature, and then we'll talk about that as we increase the temperature of the water. The water temperature now is reading about 20 degrees Celsius. That corresponds to about 68 degrees Fahrenheit. And let's add some heat energy by lighting this flame under the beaker. And I'd like to raise the temperature of the water by about 10 Celsius degrees. And so we'll see that water start to heat up. So now we have the water temperature up to 30 degrees Celsius, and that corresponds on the Fahrenheit scale to about 86 degrees. And we talked about what's happened there. We've added heat energy to the water, and the water temperature has been raised through 10 Celsius degrees. Now it turns out that it takes 1 calorie to raise the temperature of 1 gram of water through 1 Celsius degrees. Here we have 100 grams of water, and we raised the temperature through 10 Celsius degrees. So that took 1,000 calories of heat energy in order to raise that temperature of the water by 10 Celsius degrees. Turns out there's another way to change the temperature of the water and another way to add energy to a system, and that's by doing work. And now what I'd like to do is go to the back room and measure in our shop in the back room a temperature increase as a result of work being done on a nail. So here we are in the back room, and I have a nail here, a rather large nail used to tie railroad ties together. And I have a grinder here, and I'm going to let the grinder do some work on the nail and thereby raise the temperature of the nail and therefore the internal energy of the nail by doing work rather than by adding heat as we did with the water in the other room.